In this session, we are going to talk about the purpose and concept of a process flow map, and then familiarizing with the practical tools. These are flow diagrams, eco mapping, e-Sankey, and then we have an exercise. So the purpose of flow mapping is to lay the groundwork. So this actually helps in knowing more about the company, about their energy sources, about their current energy management system practices, and also to identify and document energy losses, or as we said, non-product outputs. We discussed this last time as well, that all the inputs, they either end up in the product or they do not end up in the product. So those do not end up in the product are called non-product outputs. We also use this term NPO as certain losses or certain hotspots. So for example, if we see that there is air emission inside the ambient air emission, for example, in a factory, we can also say that this is an NPO. And if you see time loss, for example, that is also an NPO. So the reference comes from, there is a requirement by the HIG facility environment module in level 1. First question says, track all energy sources. This is where this requirement is coming from. The concept is that although you already know what a process flow is, so we're going to see how we use it for energy. So systematically, step by step, we apply this approach to understand which processes are there in a company, how these processes are interlinked with each other, and what kind of energy flows are there from each, and so which processes are consuming which type of energy, and from each process what kind of energy non-product outputs or energy wastages do we see. We can also use this to refine our boundaries. So in the previous step with the company, we discussed about setting boundaries of our work. So this is where we can define concrete boundaries for, and also see what are the external operations that our company wants to influence or should influence. For example, energy produced by a subcontractor within the premises of the company. So there's a subcontractor who is producing energy, so it's not your company who is producing it, but the energy generating equipment is inside your premises. So that is what we as a company, if I am a company owner or a manager, I would like to influence it and like to see that the energy is produced in a cleaner way, and that we are not overcharged for the energy as well. So that is why we might have our interest in assessing this. Or maybe as another example of external operations, we want to know how many greenhouse gas emissions are there related to our solid waste incineration. So our solid waste is going to a third party, most probably a government approved party, who are doing the incineration. But if a company is doing an export and they are also working on HIG facility environment module, in level 3 of air emission section, they are required to stop doing the incineration without energy recovery. And they're also required to stop doing the landfilling. So in this way, if the company is at level 3 in HIG FEM, they have to actually comply to this as well. And then when we're working on energy management, we also have to keep this in view, that air emissions level 3 is also complied with or conformed with. So first of all, we need to map the process and energy flows. So as you can see, there's a factory where we have grid energy supply. So we might have emissions in the grid that we need to know. Then there's a fuel supply, which might be a fossil fuel and a non-renewable energy. So we need to track this as well. And inside the factory, we might have inefficient combustion, where we are losing some fuel. And in the emissions, for example, we might have other NPOs like waste heat, carbon dioxide, methane, nitrous oxide, which are polluting the environment. And then we might have particulate matter, or sulfur oxides, or nitrogen oxides, or smoke, which cause the visible pollution as well. Inside, we also have process or material wastages, over processing, for example, where we might have some losses. Then the product is going out and there are emissions for transportation. We have our waste going to landfill or incineration, where there are emissions to air, water, and soil, for example. And we might also have solid fuel ash, so residue going there, or the waste fuel drums going there, which might have some fuel accumulated. Then we have a wastewater flow where we might have waste heat going with the wastewater. If we are not doing a waste heat recovery, um, the solid fuel ash residues might also be going there, because, for example, we have a boiler where we are burning coal, and then we have a wet scrubber. This wet scrubber, we settle down this waste water from the wet scrubber, and the relatively cleaner water goes towards the effluent treatment plant. But this already uh, has a lot of ash residues as well. So this also goes there. And then when it goes to effluent treatment plant, we have emissions for the treatment, and then the sludge goes to the soil. These are different impacts the company might have on the environment. But when we are working in the company, we need to know which of these we want to influence. So this is where the setting boundary comes in. We had a discussion about this last time as well. So about the benefits, we already know about the benefits of the process mapping, that it identifies it, it visualizes all the processes, and we know which are the critical processes there. And we also identify what kind of wastes are there, what kind of non-product outputs are there. We can also quantify and do a mass balance or do an energy balance. We can also do a greenhouse gas emissions balance using these process flow maps. And we can then also start communicating or improvements, for example. So, and also improve our communication inside the company. So if we have a process map put up in a board somewhere, which shows which kind of energy are coming in each of the processes and which are the wastages, and if we can even quantify that, everybody knows that, okay, look, we never knew that there are so many wastes coming out of our processes. So everybody would start understanding that this is something that a company wants to achieve, getting dissatisfied with our current state, for example. So there are different tools. One is an eco map, one is a process flow diagram. I will explain about both going forward. So eco mapping is a very simple and practical tool to visualize the process flows. For this, what we need is that we need a layout of the company, and using this layout of the company, we can start identifying on the layout where we saw the wastages. So if you see, for example, in this example that I've shown, there is a map of the company, and there are this written excess heat, it says wastage. So they have marked it with different symbols, and there are different symbols everywhere in this. So if you have this map, which we call eco map, put up in the production floor, and on this map we have identified where the problem is and what kind of problem is there, then it is very easy to communicate to people that these are the problem areas, then these are what we want to improve. This kind of maps we also use for geotagging, for example. Just like we have Google Maps or Microsoft or Apple Maps, where we know which locations are where we want to go. So similarly, we can use a map, and there is an application for this as well. If you are using Apple, um, then you can also download one application for eco mapping from the Apple Store, but this is not available at the moment for Windows or for Android. And I heard that the maker of this is also trying to improve this now, and also trying to bring in an Android version as well as a Microsoft version of this application. So how to use it? Number one, take an existing ground floor map, just like this one, for example. Consider using different maps for energy, one map for water, one map for air emissions, one map for chemicals management, for example. So you can use different maps for different aspects, and then do a walkthrough. So we never prepare this map while sitting on our tables. Although we remember a lot of things, but when we go to the factory floor, that is when we see the real problems or real NPOs there, real hotspots as we call them. It is very, very important to involve workers on site. So rather than a manager does it themselves, it is important that the workers are involved, so that they help you identify the problems in the area, the situations on ground, and then fill it correctly on site based on the actual observations on site. So taking a map and then also identify that are there any water bodies around, are there any housing schemes around, where is the neighboring industry, is there a road there, for example, is there a community, a school around our factory. So what actually is there around this map that we have taken. So rather than only using, as you see in the bottom, only a floor map, on the top you see that along with the floor map, this example also shows that there are other things around. So there's a garage, there's a stock there, there is a housing scheme, 3 housing schemes there, and there is also a river there. So this is how we start. For example, take an example of this one. So this is a factory inside the black boundary, and there is other two other factories on the bottom side. There is a road on the front side as well. On the left side there's a river going there, and there are towns and villages also around. So this way we also know that who are the communities around us who get affected with our environmental performance. And then the symbols. So what symbols are we going to use to identify the problems? For example, we could use these hashed lines for small problems. We could use these circles for bigger problems, or where we need to immediately do attention. And you can see that in the example we have used thick circle as well as thin circle. So if we are doing an eco map in a factory and we are trying to identify energy losses, so if we see that there's a small energy loss, we can use a small symbol, and if we see a big energy loss, we can use a bigger symbol. So that is how we can use different type of symbols. So if you use a thin marker, that means that the problem is small, and if you want to highlight it as a big problem, we use a thick marker or a thick symbol. That is how we can, the seriousness of the problem can be highlighted with the size of symbol or the thickness of the symbol. This is one example of an eco map. So this is a floor map which actually has a lot of symbols on it. Some are for the monetary loss, some are for the danger, some are for the electric shock, some are for the hot or humid environment, or for not having personal protective equipment, or having a dangerous chemical somewhere. So these are different symbols that can be used as well. And next way of doing is developing a process flow diagram. It could be of different shapes. For example, we see this upper shape, which is more a freestyle, connecting from everywhere. And then there is in the bottom a shape which is more a structured way, going from top, from the main input, ending in the main output, and then showing the different type of symbols on the left hand side and right hand side. I will explain what these mean. So in this one, for example, the flow is represented by arrows. So for example, the main input or the main raw material is shown in the big blue oval on the top, also showing quantities. The black boxes are the process steps. Arrows are actually showing the flow of the main input and how it is being converted into intermediary products and then into a final product. So green color is used for the product flow. On the left hand side, we have with the blue color inputs. So, and on the right hand side in the red color, we have non-product outputs or the wastages as we call them. So in this example, for example, in step 1, there are water, energy, auxiliaries, chemicals coming in. On the right hand side, we have wastewater, we have air emissions, waste energy, and solid waste. So this is how we show them. And if we put quantities as well there, you can see that there are units also attached to it. If we put quantities here, we can already convert them into a mass balance as well as into an energy balance. So how do we start? So first of all, we take the company as a whole and we see what are different kind of inputs coming into the whole company. Okay, so this is a company, for example. On the left hand side, there are different energy, water, chemicals, and cloth coming in. On the right hand side, our colored cloth is going as an output, and in the bottom, it shows that there is wastewater, there is waste heat, air emissions, and there is solid waste going out. So just take an overall example of the company. So if we are doing it for energy, for example, I would say we take the whole box of one company. On the left hand side, we show which are different types of energy coming in. For example, electricity from grid, coal for steam, coal for space heating or process heating, natural gas for singeing process, for example. And this is different types of, or if we are purchasing steam from somewhere, we can also show purchase steam or purchase chilled water. On the right hand side, we can show our main product output. If it is a denim fabric company, for example, we can say that it was denim fabric, finished fabric going out. In the bottom, we can say, okay, we have coal residues, we have air emissions, we have particulate matters, we have inefficiencies for energy, wastewater heat, waste air heat, different types of energy losses that we have. So as a whole, in one go, we can see that what kind of losses are there for one company. And then we talk about individual processes. So in process X, for example, let's say a dyeing process, we have fabric coming in along with energy, steam, electricity, water, and then what kind of wastages are there in that particular process. So do we have wastewater heat? Do we have electrical energy converted into heat and also getting lost? Do we see any non-product outputs? Do we see any leakages in this process, for example? So we can then, come down to the process level then. And then we just join all these processes together to make the whole process flow map, similar to this one, for example. Here we have pre-mixing, coloring, drying, and then we have the cloth, where we have different kind of inputs coming in into each of the processes. We also have here steam generation, for example. We see 10% of the heat is going into exhaust, 50% is going to the coloring process, 40% to the drying process, and then from each of these, how much is going to the wastewater, waste heat. So this is one way of developing quantifying the flows. And then we can put percentages there, for example. So how much percent of process water is going to coloring process? How much percent of electricity, in this case, for example, 30% electricity is going to coloring process, 30% is going to mixing, 40% is going to the drying and printing process. Steam, for example, it shows that 60% is going to coloring process and 40% is going to drying process. So this is how we can start to quantify our energy flows. We can also use a Sankey diagram. So Sankey diagram then shows everything into arrows. So you see, eco mapping, as I show you this one here, is combined eco mapping for a lot of things. You can see it also shows safety, it also shows chemicals, it shows energy and a lot of things. But this is only an example. As I said earlier, for example, here, this is an eco map only for energy. So I suggest that we make eco map for one particular issue rather than combining all the issues together into one eco map. So if we are making an eco map for energy, we do it only for energy. We do not include material loss or chemical spillages or water spillages in it. So if we develop for water, then we only talk about water and we don't talk about energy. And what we can have is we can put all the maps together in different layers or put them all into one room, paste them there, and so everybody can see what is happening in energy and what is happening in water. In eco mapping, we do not need too much information. It is only to identify on site what problems are there. So I can give you a practical example. What happened was that I went to a factory where I had the workers were sitting there with me. These were really floor workers. So this eco mapping is such a simple tool that even a worker who does not know how to read or write can also use this eco map. They don't need to write these words there. They also need to put symbols. And symbols are a language that everybody understands. Once we decide what each symbol means, then we know that people can put it in. So we decide on symbols. Let's say we decide on hatch lines for leakages, be it steam leakages, be it compressed air leakages, or any kind of, or hot water leakages, for example. And then we could use a circle, for example, for waste heat. We could use another symbol of a triangle, for example, for an energy safety issue, for example, if there is a hot surface or if there is an electric shock somewhere. So we can decide on the symbols, and once the symbols are decided, we can start putting them in. As an expert, I always suggest that we use the tools very, very flexibly. So you can use an eco map as a very, very basic tool. For example, on day one, when we are there in the company doing a walkthrough, and we want to highlight issues for the company team for their awareness generation, and also to establish the dissatisfaction with current state. So we can use it on day one to set a baseline of the issues that there are there. Or once we have started the audit, we can use it as an advanced tool. How? So whatever problems we identify, we take out our basic eco map that we did on the day one, and we update it according to the latest issues that we have identified, even the bigger issues. And then we can even put up details like financial values there. For example, if there is a big circle, we could even put how many $1 million they're wasting there. So you can always improvise. We don't need to stop ourselves anywhere. We can use it as a very basic tool. We can use it as a very advanced tool. Sometimes when we are working on a productivity improvement project, for example, we use it in a very advanced manner. We also have a very long sheet in which we record what is mentioned there. So for example, if there is a symbol, a circle symbol there, in another separate sheet, we record that what does this symbol mean in location A. For example, we divide the whole factory into locations, and we put up codes like A1, A2, A3, A4, A5. And so for example, in this location, I say this location is A1. And in the A1 location, I have two symbols. One is a hatch line and one is a circle. So in this additional sheet, I would also write in detail, what does this circle mean in A1 location? And what does this hatch line mean in A1 location? So this is an advanced way or a detailed way we could also use this. But you do it on the first day when you start your assessment work in the factory. So so you go to the factory and you have started the assessment. So you want to explain to the team why we're here, and you also want to, with the team, also want to establish a baseline of the issues. So you explain them this methodology first, and then you ask them to print the big maps. So you get a big printouts, take colored markers, for example, take different colored markers, decide on symbols, and tell them that we are only going to identify the issues that we see visually, not the issues which are hidden. So normally when you go to the factory, more than 50% of their energy losses are visualized. So you can visualize if there are uninsulated surfaces, you can visualize if there are leakages, you can visualize if there are noises in the motor, for example, or if the pump is doing knocking, if there is knocking in the steam pipes, for example, if there is air emission going out, if the water discharge is hot or not. There are so many issues which you can identify only visually. More than 50% of the problems are visualized. So you go there and only identify. You don't need to quantify at this moment. Some issues you can even quantify. For example, how many leakages have we identified? So number of leakages we can quantify. How many steams for valves were uninsulated? That is something you can quantify, but don't do measurements at this moment. So do this as a preliminary assessment or as an initial assessment or a baseline assessment, and then save it. Don't destroy this map. When you go for a detailed assessment, you can always pull out this map and then update it based on your detailed assessment afterwards as well. So as I said, you can detail it according to your need and the situation in the factory. And you can then also use it for reporting purposes. You can also use it for monitoring purposes. So imagine that you went to the factory, did an eco mapping for preliminary purpose, then you updated it according to the actual measurements afterwards in the detailed audit as well. And this is in the report now. In the monitoring, then you can go to the factory and ask them which of these issues in the eco map have been resolved. So you can mark them with a green color marker, for example, as resolved. What I normally try to use is I try to use stickers. So rather than using markers, I put stickers on the map with the symbols on these. So if an issue is resolved, we take off this sticker. So when we take off all the stickers, this means all the issues have been resolved. And with the workers, it works perfectly fine. So if we are using it with workers, we try to focus on those issues which are related to the workers, which are around the machines. When we're working with management, in addition to the issues that are around the machines, in addition to the issues that are in the machines, we also ask management to identify issues like administrative issues. For example, if there are gauges missing, okay, if there are pressure gauges missing, if you've identified that workers are using high pressure air to clean machines rather than using low pressure air, so these kind of issues can also be identified. If we are at a preliminary stage, we might not have so much details available. So when we're doing it first time, we might not put quantities there in these blanks. We might only put the words here. Okay, if there's water coming in and then there is wastewater going out. In the next stage, then we can put quantities, because remember the textile company in the case study that we did last week also wanted us to fill in HIG FEM data, and in HIG FEM it requires them to do a energy balance as well. So to do an energy balance, we need to put quantities here. So you can use low detailed version, you can use high detailed version, depending on how much data do we have. We're going to do a exercise. Objective of the group exercise is to identify and map energy flows in a company's operations. What are we going to use? We are going to use flow diagrams, and we're going to use eco maps to answer the questions. So this is the layout of the textile company. This is the same textile company for which we had the group activity last time. So this time I'm going to share with you a story. This story is about the walkthrough assessment or the preliminary assessment that you did in this factory. So you went to the factory, you observed some things, and the observations are mentioned in this story of 3 pages. And this is the layout of the company. So what do we have here? We have a factory gate here, offices, workshop, powerhouse. Here is the entrance to the factory. We have a compressor room. At the entrance, we have raw material store where there's yarn. Electrical yarn means the fiber, electrical equipment, beams, other auxiliaries. Then we have a chemical store here. Here we have diesel drums storages. We have coal storage here. We have some boilers and thermal oil heater stored here. This is the finished goods store. In the bottom, we have a water tank. We have a ground well, water pumps, water softening plant. The processes are like this. We have a ball warping process. So ball warping is actually what it does is that it takes yarn cones, it combines them together and it can clubs them like this, in a rope form. It converts all the yarns into a rope, but it's a loose rope. It is not a very tight rope. This rope then goes to the rope dyeing process, where this because this is a denim factory, so we do not dye the fabric, we dye the yarn. So the yarn is fed to this machine in form of ropes, multiple ropes. They go in the rope form like this, and the whole rope is dyed and it comes out. And when it comes out, and when it dries down, it goes to the weaving hall. In the weaving hall, there are looms on which they convert it into fabric. It comes out from there. We put this fabric, we re-beam it. So put it into bigger beams, for example, and then sizing material is applied. Once the size is applied and the fabric stays there for some time, then it goes for the next stage. Then we go to the desizing process, where we remove all the sizing material, the starch that is applied here. Then it goes to singeing. In singeing, the fabric goes through a flame. So there's flame coming here on this side as well as on this side of the fabric, and it burns extra fiber of the, and also improves the shine of the fabric. Then it goes to mercerizing, where we control shade of the fabric. It goes to stanter, where the fabric is dried and the shrinkage is controlled. So size of the width of the fabric is controlled here. And the fabric that comes out goes to the packing area. And after packing, it goes to the finished goods warehouse. That is how the whole process of the textile company is developed. On the right hand side, you see a river. In the bottom, you can see that there are communities, villages, and there are garment factory on this side as well. Here we have the road. So this is the ground floor plan. What we have to do is we have to document the process and energy flows. We have to identify possible non-product outputs or energy hotspots in an eco map. Then we have to identify internal key stakeholders and decide who should be involved into company's energy management team. So we have to propose an energy team of the company. Then the question would be, do you want to make any changes in the assessment plan that you made last time? And also point out areas where we need to do in-depth analysis or we need to do measurements.